Hello students, my name is Sumit Mehta. In today's lecture, we are starting a new chapter named as linear programming. So, in the exam, there will be a definitely one question of 6 marks out of this chapter. Okay, so and this chapter is very much easy. Okay, and so you need to prepare this chapter thoroughly to score 6 out of 6. Okay, and you'll get it very easily, students, also. And so let me tell you the two theorems on which this chapter is based upon. The theorem number one, let me write it. Let RBA be the feasible region. Let R be the feasible region for a linear programming problem for a linear programming problem, and let z is equals to ax plus by be the objective function. So when z has an optimal value, when z has an optimal value, either minimum or maximum, where the variables x and y are subject to constraints by linear inequalities. This optimal value must occur. This optimal value must occur at a corner point. Means in this chapter we will be given a lot many inequalities of the form z is greater than equal to ax plus by, z is less than or equal to ax plus by, and we need to solve these equations graphically, and we will get the optimal solution at some corner point. Okay, let me rewrite let me write the theorem number 2 once, and then we'll discuss further. But theorem 2 states is, let R be the feasible region for a linear programming problem, for a linear programming problem, and let z is equals to ax plus by be the objective function. If R is bounded, if R, capital R, region, R means the region is bounded. If R is bounded, then the objective function z has both a maximum and a minimum value on R, both a maximum and minimum value on R, and each of these occurs at a corner point, or you can say, and each of these occurs at a corner point P. So students, these two theorems are the basic fundamentals to solve the two linear programming problems. Okay. So now let's discuss one question based on it, so you will get the feel of it. Okay. So students, now we need to solve this question, okay, in which we are given that z is equals to 4x plus y, and subject to the constraints that x plus y is less than 50. So we need to make a graph. Okay. And we need to select the units of the graph very wisely. So let me take the graph of 10 units. Okay. So this is so this is 10, 20, 30, 40, 50, 60, 70. So according to the first condition, x plus y should be less than 50. So this is the line touching both 50. So let me change the color. So this is the line x plus y is 50. So as per this line, this is x plus y is equals to 50. So it should be less than 50. So the region should be here. Means in this region, towards this region, x plus y will always be less than 50. Okay. And the second equation is 3x plus y should be less than 90. Okay. And this equation, students, I hope that you can draw these straight lines on the graph by checking from which points this line will pass. If you will put y equals to 0, you will get x equal to 30. So this line will pass through 30. Okay. And 3x plus y is less than equals to 90 shows this region. Okay. And x greater than 0 and y greater than 0. So the region what we are getting is, the common region is this region, student, because our solution should be below this line and below this line. So this is the common portion. So as we have discussed in two theorems, that at the vertex either we will get the maximum or we'll get the minimum. So there are four vertex or the corner points: 0, 0, 30, 0, 20, 30, and 0, 50. Okay, and the value in which 0, this is 120, this is 110, and this is 50. How I have written here these values? Because at 30, 0, the value, if you will find out 30, 0 in this equation, z is equals to x plus y, you will get z as, these are the values of z and these are corner points, and we need to maximize the z. So the maximum value of z is at 30, 0. So this is the point at which z is coming out to be maximum. So this is how we need to solve the linear programming problems. So I hope students now you are pretty clear about how to solve linear programming problems, and in the next lecture we'll discuss some more questions based on it. So stay tuned for that lecture on linear programming problems. Thank you. Happy learning.